Well, we can start now, and today we are going to talk about the mixer to do, and from another perspective, we will, apart from mixer, without the mixer server, how to Envoy to observe the observability, and I'm Sheng and Lizan Zhou. Actually, we are a kind of service mesh company, commercial delivery in North America. And first of all, my partner Lizan will do the speech and to tell you what kind of services and characteristics we're using of Envoy, and I will just tell you about how can we achieve the following capabilities regarding it. Hello everyone, I work in Tetrate, and I was born overseas, so I'm not accustomed to deliver speech in Chinese. This is my second time. So this is my second time doing the speech in Chinese. So first of all, I'd like to introduce what is Envoy. I think maybe some of you are familiar with what is service mesh and what is Envoy. And I would like to talk about some observability of Envoy. And also Sheng will just tell you how to connect Envoy and Istio to SkyWalking. First, what is service mesh? Actually, service mesh, by connecting the network and to make it transparent to applications. So many of the common functions needed in the network, including the connection pool, and this kind of function can be done in Envoy. And Envoy can just replace many of the following applications to achieve the function needed in the network. So these are for the general service mesh, how they deploy. Well, the common thing is that the Sidecar proxy, to use the Envoy is the Sidecar proxy and to put in every service part. And then for every service and application through this kind of Envoy service proxy to communicate. And Envoy, I have said it in my previous introduction, what is another other process architecture, and we achieve it through C++ and to achieve the high performance with low latency code base. It has many filter architectures and also has support for the HTTP-L7 filter architecture, and also as for the service discovery and kind of observability, what is the emphasis we're gonna put today, as well as the authentication, authorization, and edge proxy. So these are the general architecture of Envoy. You can also see it in other places. Listener filter. So what kind of filters we need in this, and this can provide more information to it. It's a kind of encoded filter, and to do it in different ways to encode this kind of linkage. And we will use TCP, and also to in our support service in like other double L7 rate filters. So actually, once you understand the L7, it will provide more observability. For example, how many requests, how many responses, and the logging will also be much more improved. And these are one character of Envoy, that is the API, which is a control plane, and to provide a different configuration for Envoy. a listen discovery service, cluster discovery service, and route discovery service. And in terms of observability, there are two services. One is metric service, and another one is access log service. Also, we have the trace service, which is we haven't fully finished it. And today, I will mainly talk about the metric service and the access log service to achieve the Envoy and the SkyWalking connection. As for observability now, let's first look at the metric service, actually, which is a very easy service. We'll just identify one IBC data stream, and we can see this matrix is using structure from Prometheus, which means that which envoy in which cluster is this envoy, and to identify the. And as for the access log service, it's very easy too. It's similar, and we can just HTTP access log entries as an example, which we can see for every filter. We can add some of the unique data in it, and also to add one identifier. This is the streaming to this log service. So in SkyWalking, we have a metric receiver. This is expansive function of SkyWalking. And in the support of the SkyWalking, to support the metric service and access log service. So we want to connect Envoy to the SkyWalking. We need to send to this service, access log service, because I've mentioned in access log service is mainly in the HTTP connection. So in every listener, the connection manager needs to be realized. So next, I would like to invite Sheng to tell us how we can receive this data in SkyWalking. Well, Lizan have told us about the two services we are going to use, and these two services we can simplify them. We just got two data. One is the Envoy connection, the app, and some of the regular information. As for the access log, actually, we are getting the kind of other information. We usually use ISO to manage the kind of orchestration of Envoy. So whether it is tracer or metrics or our many topology by many of the producers. So by the end of last year and the beginning of this year, if you want to, in some of the open source community to propose this adapter, you want to do the mixed adapter, you want to do the in-process adapter, you will find that actually Istio team will not clearly receive this PR. They want to tell you, I want you to achieve bypass adapter. What is bypass adapter? Which is the Istio Envoy filter to send the data to the mixer server and according to your information to send it out. So actually it leads to kind of bypass. So actually SkyWalking is the only one that can achieve bypass adapter in the open source community.
During this process, actually mixed server doesn't do anything. It's kind of like just a root. And in a lot of articles, the concern of most people is the performance of mix adapter and the mix and Istio Mixer. So the performance concerns are actually the following. For instance, the Envoy filter cost, it has more CPU. It needs more CPU of Envoy, and if you actually look at these filters, the most complicated thing is that it needs to actually put more information inside, and what are the sources and destinations, and in the mixer, so the metric you could actually see, you would receive the information about the source and destination. And also another problem is latency of RPC. We need to actually have this issue be higher procedures, and latency cannot be avoided. And the mixer actually has done a lot more than zipping, and in terms of the tracing. And the mixer is more complicated. And you can see that the telemetry, it collects more data. And the second concern among people is that when Istio wants the other users to use the bypass, but there would be unnecessary cost when using bypass. Whether it's just a little more cost, then people would still consider it unnecessary. And also, the third concern is the Istio filter to server. It's kind of like a protocol is quite complex. And we have this complex attribute report protocol. And Istio's team is trying to lower the complexity, but it's still not user-friendly enough. So if we say that we don't want mixer, and what is the things that we need to do in terms of observability? And observability is like include metrics, not, and tracing. So tracing is not mysterious, so we all know how to do it. And we need to have SDK, and then need to have agent, and then we need to go into this kind of like process and the metrics. So there are two main metrics. Whether it's be it Prometheus or other systems, it means not mean. So the metrics have not analyzed, and then we also have topology. So Mixer actually provides much more powerful capability in terms of the topology. And so for Envoy metric surface, so on the basis of Prometheus, actually you could get all the Envoy metrics, and your application can get to APM system, including Prometheus or other systems. But if we do not want those, then how can we match? And if we don't change anything, how can we get the topology that we want and all the values of the metrics that we want? So if we take out Mixer, what are the other options? So SkyWalking is an open source project, and it can have C++ plugin, and it can add filters inside. It's kind of like Yammer, what Yammer is trying to do. And also through tracing and analyzing tracing. And 3 years ago, through the foundation until today, and it can do all the tracing and details of tracing, and this is just an open source APM system. That's the first option. Second, so we can actually implement the Istio attribute protocol, which is quite complex, as mentioned. And so it's complex. It's just relative, but not mission impossible. So it's just a protocol anyway. But then if we can implement the Istio attribute protocol, the filter is still working. So the Istio's filter this problem cannot be addressed. And the impact on latency and etc. are still there. The third option is LS. So what is LS? So whether you are, be it like if you are familiar with Envoy or other gateways, access log is actually the log output of every request. It is a service, and it is through GIS, not via. So it has access log and access log service. So actually they are same on like from certain perspective. So Envoy, so you can see they actually ALS have two different roles. They can have Sidecar or Ingress, those two different methods. So if you look at the mesh topology, and the Sidecar is the application behind it, and it's kind of like an agent. And then if it's a gateway, Envoy itself is the service. So we want to show the topology. The topology that you want to have is totally different. And the first problem that you need to solve is to tell whether it's Ingress or Sidecar. But Envoy actually doesn't know. But fortunately, we still have Istio. Istio's pilot, when they name every envoy, they have quite a regular pattern. So for instance, the pattern includes the name of the node, and actually they contain very important information. If it's Ingress, it is named the router. If it's Sidecar, it's named like Sidecar. So you can see the naming pattern here, and to realize what it is. And also we have different requests. And we have inbound and outbound, and client-side Sidecar, and it's also like Istio is controlling Envoy. That's like, if we just run a normal Envoy, it doesn't look like this. And inbound, outbound is that like we tell Envoy which is outbound and which is inbound. So LS, like actually we can activate it anywhere. But then if we want to actually make the observability work, we need to have like this mesh and follow all the rules of Istio, all the controlling rules. And for instance, the naming and everything, you cannot have your own envoy that you can assume that it would work. It doesn't work that way, actually. So I just skipped the previous slides because like a lot of things are specific on the Kubernetes platform that you could see that we have one very special thing, is that something that you wouldn't normally see. So this is the data here that you could see doesn't have the concept like pod. And what you need to do is that you will see the IP here. And for the service mesh and Kubernetes, what are the features? So it is like specific in a specific time. So there would not be two pods sharing one IP. So every IP is specific, is distinctive, and you can, if you can have like two pods taking like a similar or a same IP, it's not what we are looking for. So if we look at any monitoring system, we can only receive IP of the service, and we don't know the progress of that. So actually the IP is the most important thing. We need to get the IP to locate what is the original service and like for instance the data of service A and the service B. So when we try to pull out the data and on each topology that the data is generated by ALS. So I want to tell you specifically that there are different cases. Ingress, so it has a special role. For every incoming request, it will have a specific ALS. So on a topology, you will have two lines. Because Ingress itself is a service, you need to have this kind of like, you need to visualize its incoming and outgoing to make sure that it is an independent service. And then server-side sidecar, so it's service-side metrics. And also, we can show that who is pulling out the data, who is collecting the data, and also there's something specific that when you use Ingress to pull up the sidecar, Ingress is it will actually go through the IP address and you cannot generate this line. And on this line, this will only have an ingress for the target service, and the service cannot trigger the ingress. So this is from only can be achieved one side, and the client side sidecar is the same. So we just talk about how can we identify those. It's quite abstract, but then we also have this kind of like open source Apache SkyWalking, so you can see the project repo here by visiting this website and all the metrics and websites there. So this is all we want to share. If you have any topics that's related or any questions that you want to ask, please don't hesitate to raise your hand. So actually I do have a question. The first one is that through avoiding mixer, so observability of Istio, so can you also cover the observability of the nodes, and can you yes, yeah, it's actually the same, it's consistent. The second question I have is that you cannot, we cannot have like just a standard Envoy. You still need an Istio on the NVS and have this Istio. So you don't need a filter actually. You need a pilot. So actually, for Istio itself, Istio proxy, so we will have this Envoy and also the mixer shelter. And we don't need shelter. For that part, as Sheng mentioned, for this the naming rules and the pattern and everything, the identifier, we need to give it to the Envoy. And if you use other Envoy, you don't have a consistent naming patterns or rules. So we want to use like pilot to identifiers to achieve the result. So that means that I only need to replace the current Envoy that I'm using to the standard Envoy. Is that right? Is that right? So in theory it works, but we haven't tested. So, but I think you don't need to change it into Envoy because there's no Istio filters. So how can I avoid the cost or lower the cost of filters? So in the configuration, if there's no Istio filter, so you can just turn off and it will not generate any cost. Have you ever compared the performance? So I think Mixer is quite slow. So if I turn off filter, so actually we haven't done any large-scale testing. So we don't have this kind of like application case scenario. So for a single node LS, if we We actually have tested single node. The performance, so we will have an extra of 10 to 15 extra cost. That's what we noticed. So actually, it has a lot of things to do with the traffic as well. And the cost we will have an extra cost of CPU about 10 to 12%, and there was no impact on the latency. And the mixer is just not only about the mixer, but also about the latency. So thank you very much.
And the pod is too much, and there are around 1,300 pods, and topology just cannot work on it, so the memory is not working. So we have two things. The ES is the core, will be the core. Because the topology doesn't have any logic for the tracking. So this is a kind of basic logic, and all the metrics, they are after the second search. For the very big issues, and maybe next version would be better, but for these version, you should remember that due to yes, performance for the deletion will be much more than writing. So TTS will have a much bigger pressure. So after running for a while, don't have any data because it's not the data has been, it's the delete has been. Because before delete, you have saved data. Because the matrix cannot be saved forever in PDL for several several minutes, several hours, several days. Actually, it is a big pressure. So we have very big ES cluster. It's quite big. We didn't find what is the big problem with it, because there are not any specific signs upon the deletion, but many people asking it. And our solution now is that we will just delete these kind of indexes instead of delete the data. That is the ESDDL. And only be set in the level like days. So you can only delete the indexes, everything. So your ES data needs to be able to work on at least 1 day. If it only can be work for several hours, it cannot work. So if I want to see the observability and the topology, actually we can just shut down all the things in Mixer. Yes, all the Mixer related can be turned off. Thank you. As the plan had mentioned just now, the Istio still needs to be maintained, and pilot still needs to be maintained, and we only can delete all the if you even don't want the pilot, actually, as long as you can just obey the rules I mentioned, you can identify the gateway, the sidecar, and this is inbound and outbound. And if your SDS can also have the same function, it's also fine. I'm just saying that Istio is much easier way. So as for the RS, source. So actually, in the SkyWalking document files, you will see there's one point I need to manually change the code because this operation of the iOS in the pilot it cannot achieve, but our PR cannot be fully integrated. So for Envoy, it doesn't necessarily need to be do that. Yeah, iOS was working on long time ago. Hello.
这样我看一下，如果我们现在实验方式有人用一个 hack 方式，对吧？有没有可能把它作为或者规范以后，我们去考虑把它放到并且说 SMI 里面去作为一个基础的规范
regular way to achieve it. SMI actually is relatively complicated because for SMI you need to ask the Istio community. Well, what I'm saying is that I would consider SkyWalking to standardize the metrics. If the next version of SkyWalking pilot is changed, it might not work for us. Actually, it's the first time we're telling everyone, for this plan we have achieved several months, and someone has told us that they have do it for several months. It's the first time that we have shared with everyone. So previously we didn't done any kind of things publicly, but with the time passing we'll do the following works. But SMI or other things or issues, actually it's still too early for us to say that. I think it's quite good. But maybe we need time for everyone to accept it, because no one has done it before. There's an official file if we just use maybe we can try it to shut down the mixer and to. So actually what I'm telling you to you today, we will just turn it into the plan, into the blog, and I will tell you about the PR. And you know that once I change this code, because SDS, I changed SDS has been added on. I will tell you about this, and according to the current stable Istio, and to change one or two of